to me, the lesson is be brave and try crazy things. Because at the end of his talk, he mentions that they managed to get like a 30% improvement in efficiency
Over PyTorch?
over PyTorch. So that they implemented basically the same model and they ran the same training, which was basically GPT-2, and it was 30% more efficient and faster. So clearly, I mean, PyTorch is a good framework, but there's always room for improvement.
Welcome to Practical AI, everybody. My name's Jeff. I'm with Peter Lynn. We are in our second season of Practical AI, and we are sponsored by Pocket AI. Pocket AI is a tool used to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights of your model while increasing accuracy. Peter, one of the big minds in AI recently did a little experiment. Most people know who Andrej Karpathy is, and he, I think, formerly Google and OpenAI and some other places, he did a little experiment. Now, you and I talk a lot about writing your own or building your own model, as opposed to doing transfer learning. This guy took it a step further in terms of AI, and he did something even more profound and more grand than just starting from scratch with a model. What did he do?
What he did was he was having so I recommend people watch the video itself. If you're a programmer, if you're into AI, definitely watch it. Basically, he was using PyTorch, and it gave him a compiler, meaning that he was trying to create a model, and when he went to compile it, PyTorch said it gave him an error, and he was like, "What a pain." So his thought was like, "Well, I don't want to spend months figuring out PyTorch. I can just write my own in C." So he did that as an experiment.
In C language.
C language, yep.
Yeah.
Yeah, and for those who don't know, like PyTorch has been around for quite a while. It's got a lot of parts. It's huge and it's mature and it works well. But it also means that if you're a researcher and you want to fix something, for you to actually read their code, understand it, and fix a bug or change how it works, it might take you 6 months to a year because I mean it's like millions of lines of code.
And
There's like
what's
stuff.
what's PyTorch written in?
It's written in C, C++, Python. It uses CUDA, um, and they're probably supporting their own AI accelerated chip. So there's just a ton of stuff in there.
Yeah. So you'd have to learn
Oh,
several languages just to get to be able to maintain it and support it. Okay.
exactly.
So he's running into problems. He knows it'll take him too long to understand and learn everything there is to learn about PyTorch. So he takes a left turn without a blinker and says, "Fine, I'll just write my own model."
Yep. Well,
But
his own framework.
how hard is that? Yeah, write my own framework. Sorry, right. How hard is it to build and write your own framework?
Well, apparently the base framework took him a couple days,
Okay.
which seems about right because he used to teach the Stanford machine learning course when he was there. So he's done it before. So he was like, okay, I've written models from scratch in Python before. And so the question a programmer asks is, how hard could it be to write it in C?
Yeah.
Well, it turns out the first part is pretty easy. It took him a couple days. But then the next question after that was, okay, so now I got it working on a CPU. I've got GPUs, and how do I make it run really fast on GPUs? And in one of his slides was, how hard is it to learn CUDA? Because he's never used CUDA, or he only used it a little bit in the past. And so he started this journey of like, okay, now I'm going to add CUDA support so I can train on GPUs. What turns out is really hard.
And again, so for the listener, the CUDA is the essentially we'll just call it a framework as well, but it's it's a language or a series of languages that sits inside the GPU land. So for NVIDIA, it's their special sauce for software that makes stuff run really, really fast.
Yes.
And this has been in the works. CUDA has been sort of under development, this software behemoth now for years and years and years, right? And so this is millions and millions of lines of code as well. And he kind of ran into a brick wall there, right? Trying to figure out how to learn
Yeah.
CUDA.
Yeah. So during his talk, he mentions like, well, I read these two books about CUDA, but he actually learned the most and found more answers from people from Anthropic, because people Anthropic have come across the same problem of like they wrote their own framework and then they needed to get to work on CUDA. And so luckily other people have gone down the same path of like, well, I don't like this framework because it's not doing what I want. So I'm writing my own. And then you then come across this issue of like, I need to learn CUDA now, but CUDA has things for like gene sequencing, scientific computing, finite element analysis, just a whole bunch of scientific computing libraries. There's probably 3 or 4 dozen different scientific like domains that they provide accelerators for, and it's super popular. So like everyone uses it.
It kind of reminds me back in sort of the software stack days when Oracle came out with Oracle Manufacturing and Oracle Finance and all these parts and pieces that were specific to an industry solution. In this case, it's computing solutions or computational solutions that are specific to a specific line of math or gene sequencing or whatever.
Yeah, so yeah, there's accelerators for each domain. So like protein folding. When I was in college, there was folding at home, which is protein folding. When they first started, you could download the software and it would use your CPU in the off hours and it would use it to train. And then there was SETI at home, which was take down the satellite data, use your free CPU time, and it would process the signals and try to figure out was there an alien signal. So both of these projects started in the 90s. And then when CUDA came out, they both adopted it because they realized, oh, we could like speed up all of our work by 10 to 20 times, sometimes 50 times.
So is the lesson of what Andre did that Andre's an arrogant, idiot and he should have never done this. He ran into a brick wall, or is it something else?
To me, the lesson is be brave and try crazy things, because at the end of his talk, he mentions that they managed to get like a 30% improvement in efficiency
Over PyTorch?
over PyTorch. So that they implemented basically the same model and they ran the same training, which was basically GPT-2, and it was 30% more efficient and faster. So clearly, I mean, PyTorch is a good framework and it's really useful and it's big and there's hundreds of people supporting it and working on it, but there's always room for improvement. And
And
we're
then
talking about,
from his perspective too, he actually learned something as well. So from a sort of personal selfish perspective, his big, crazy, audacious goal was good for him, right?
holy, yep. Well, not only that is now, if you want to learn what he learned, you go to GitHub and download LM.C and you can see his progress and you can learn from his mistakes, which for me is one of the best things about open source. Having participated in open source for 20 years, when you see the like version one of a piece of software, and then you track that progress over 20 versions, you can see, oh, okay, so and so made this design choice and thought this was the right design. And then over the versions, we're like, oh, actually, that was garbage. And then you get to learn from their mistakes of like, yeah, the initial assumption was naive, but as they moved along, they realized, you know what? Half of that was just garbage. And so we made design choices that were really not true. And as they evolve, you can see you kind of, oh, okay, all these assumptions that we thought were true were not true. but they drove design, and that caused us to make these choices, which now we have to revert, we have to replace. And in that process, you learn a lot about kind of making wrong assumptions about things or assuming you know the answer before you actually see the problem.
Yeah, it's amazing how much value there is in the errors that we make, and yet how usually we are reluctant to share those or admit those. But that's where everybody learns the most, is in the middle of these errors.
Yep, exactly. Yeah, I mean, like my time contributing to Apache, I learned more from reading the source code as it evolved than writing my own code because I could see like, oh, okay, like all these grand plans about like this will do all these things. It just wasn't true. I mean, it's good to be audacious and have lofty goals, but it teaches you to how to keep things simple while trying to achieve these lofty goals.
Well said. All right. Well, thanks for the thing. We'll post that video in the description box, and encourage you to watch it. It's techie, right? This is a very techie discussion with amongst other techies, but it's cool to see him take an audacious idea, struggle through it, and then share it with other people, and how people are super excited to see this, and
Yeah,
he gets a good product out of it too. He gets a pretty good functioning model or framework that'll run models.
yeah.
Peter, thanks for the time, and we will see everybody next time. Take care.